Solution of the initial value problem. Y dash plus 3y plus 2 integration 0 to t y dt equals to t and the y of 0 equals to 0. So if we apply the Laplace transformation on both sides of the above equation, we will get s y of s 3y of s plus 2 by s y of s is equals to 1 by s square. So s square plus 3s plus 2 y of s is equals to 1 by s. So from this, y of s is nothing but 1 by s f of s. Here f of s is 1 by s plus 1 s plus 2. Now y of t is nothing but integration 0 to t f of t dt. So 0 to t e power t e power minus t minus e power minus 2t dt, which is nothing but e minus e power minus t plus e power 1 by 2 minus 2t 0 to t. So if we substitute e power minus t plus 1 by 2 e power minus 2t minus of minus 1 plus half, so we will get this as 0.5 e power minus 2t minus e power minus t minus means plus 0.5, which is option B is correct, D is correct. The figure shows the block diagram of a feedback control system where A equals to 30 at angle 60 degrees, B is equals to 60 at angle 30 degrees at a certain frequency. The value of the block C for the system to oscillate is. So in order to decide the value of C, we have to first of all find out the closed loop transfer function, that is C of s by R of s. If we find, we will get it as, that is we can write g of s by 1 plus g of s h of s. So here g of s is a b by 1 plus a, h of s is c. So c of s by r of s is equals to ab 1 plus a divided by 1 minus abc divided by 1 plus a, which is nothing but ab 1 plus a minus abc. So for the system to oscillate, 1 plus a minus abc should be 0. That is c is nothing but 1 plus a by ab, which is equals to 1 plus 30 at an angle of 60 degrees divided by 1800 at an angle of 90 degrees, which is leads to 0.0169 at an angle of minus 31.68. So the magnitude of the block C is nothing but 0.016, that is option C is correct. It has following specifications. Total output offset voltage is equals to 479 millivolts. Input offset voltage is 4 millivolts. Find the input offset current. Here feedback resistance is 500 kilo ohms. Here total output offset voltage is equals to input offset voltage multiply with gain, that is 1 plus RF by R1 plus input offset current into feedback resistance. Here input offset voltage is given as, means if we compute this portion, that is 4 millivolts 1 plus 500 by 5, which is nothing but 404 millivolts, means output offset voltage because of input offset voltage is nothing but 404 out of 479. So the offset output voltage contributed by the input offset current is this one, that is IIO into RF is equals to 75 millivolts. So input offset current is nothing but 75 into 10 power minus 3 divided by 500 into 10 power minus 3. So 150 nano ohms is the input offset current, hence option B is correct. Of t and y of t are jointly White-Sense stationary process, and h1 of f and h2 of f, the filter functions, have non-overlapping pause bands for all f. Then v of t and z of t are. See, if we calculate cross power spectral density between two signals, that is v of t and z of t, we will get it as svz of f is equals to h1 of f conjugate of h2 of f into xy of f. Already in the problem statement, h1 of f and h2 of f having means they don't have any overlapping pause bands. That means the product of these two is equals to 0. Hence svz of is equals to 0, which means the correlation function also 0. This indicates that v and z are orthogonal to each other. Hence option A is correct. E power z is equals to 1 plus I. Find the value of z. Here z we can write as x plus iy. So e power z is nothing but e power x plus iy. So e power x into e power iy. So e power x, e power iy can be replaced with cos y plus I sin y is equals to 1 plus I. If we compare LHS and RHS equations, then we will get it as Ex cos y as 1 and Ex sin y is equals to 1. So we have to decide the values for x and y. So in order to decide the value for x, we have to remove the variable y. So we have to square these two equations, that is this one and this one, and add together, that is Ex cos y whole square Ex sin y whole square is equals to 2. So e power 2x is equals to 2. So x is nothing but 1 by 2 natural logarithm of 2. Similarly, we can solve for y, that is tan y is equals to 1. So y is nothing but pi by 4 plus n pi. Hence z is nothing but x plus iy 1 by 2 natural logarithm of 2 plus I n, that is pi by 4 plus n pi. Hence option C is correct.